Good afternoon. This is Kristy Olive with EnSafe, and we're going to be talking about household chemicals with a focus on a short toxicology review and some case studies about how to handle those. Just wanted to get started. One of the reasons that I wanted to kind of review toxicology was that recently I sat in on an AIHA e-learning series on toxicology, and I thought that was a really good refresher for me. And so I thought, well, we need to dig into a little bit of this before we start talking about household chemicals so we can think about exactly why we are concerned about household chemicals. We hear a lot more about this today than we used to. I know I've got several people at my church that just won't use any household chemicals because they're concerned that they may have toxins in them. So I just wanted to kind of start out with a review of toxicology, and then we'll get into some situations I've run into in my career with household chemicals in the workplace. Just letting you know, I've done my best to research this and find material that's available, but I make no guarantee that this is complete or that you could take this and then run and become a toxicologist. I'm a certified industrial hygienist, but I'm not a toxicologist. We're going to start out today trying to meet these objectives. We have general toxicology review. We're going to talk a little bit about SDS reviews and how to determine if it's a pretty good SDS, because we've all seen those that look like somebody typed them on their typewriter at home and they just don't inspire confidence. So we're going to look at a few and see what things the toxicologists are recommending that we look at to determine if it's a valid or a good SDS to use going forward. We're going to talk about uses of chemicals in industrial versus household settings. So it's different, especially when you get to the waste side. It's different whether I'm using Clorox or Windex in my office or using it at home. Different rules apply. You get some exemptions when you're using things at home because you're using it in a more dilute form, and you're also probably not using nearly as much of it. If you're cleaning the windows on a whole building, that's a lot different than cleaning the windows on the front of your house before you have company. We're going to talk about controlling household chemicals brought on site and how that can affect your day-to-day safety. And then we're going to talk briefly about the disposal of household chemicals. Of course, we've got guys at EnSafe that know all about industrial waste and can help us out with that. So if you have questions about that, please put them in the chat and we'll get back with you after the meeting. So we always start, what is toxicology? Well, it's the study of poisons. Well, what's a poison? Well, back in the ancient times, Paracelsus said that all things are poison, and nothing is without a poison. The dosage alone makes it so a thing is not a poison. And we've kind of narrowed that all the way down and drilled it down to say the dose makes the poison. So anytime you're talking to an industrial hygienist and you say, is this a safe chemical? They're not going to want to answer you, because how much of it you're using, what you're using it for, what you're mixing it with, all those things determine whether it's poison in that setting. So we took all of this long phrase that Paracelsus said back in the day, and we drilled it down to the dose makes the poison. So you'll hear that a lot when you're looking at industrial hygiene and toxicology within the field of industrial hygiene. So if we're going to talk about the dose making the poison, there are some target organs that if you've taken the CIH exam or plan to take the CIH exam, you'll know that when you're reviewing all that study material, there are some organs that seem to get all the press. So there are 78 organs in the body. We're not going to talk about all 78 today, but I wanted to focus on the 5 that you kind of hear the most about, that you kind of hear. These things are the ones that us industrial hygienists get kind of hung up on, but it's good to review it. First of all, you've got the liver, and liver toxins are called hepatotoxins, and we're going to talk about those briefly. Kidney toxins are nephrotoxins. So if you see the word hepato, you're looking at the liver. If you see the word nephro, you're looking at kidneys. The nervous system or neurotoxicity. You hear a lot about that lately. People having brain fog and people being sleepy and people having excessive fatigue. And we'll look at a little bit about what, if you're looking at a neurotoxin, what effects those might have. We'll talk briefly about the lungs, pulmonary toxicity. I tried to find one word for that like I had for all the others, but I couldn't find one. If Pulmonary toxicity is another concern. You know, that's kind of the birth of industrial hygiene, are things where we had lung problems, and people immediately associated that with things they breathed in. So we got pulmonary toxicity. And then finally, you have blood toxins or hemotoxicity. And of course, our blood flows throughout our body. The thing about all these systems is that they interact. So anytime you have a toxin and you're looking at that SDS and you go and you look at the toxicology section, there are going to be what they call primary and secondary toxicological effects. So a toxicological effect is how this poisons you. So I get into this chemical, I get poisoned, something bad happens within my body. So I didn't used to be allergic to poison ivy, but poison ivy produces as what they call a xenotoxin, which is just a toxin produced by a biological means. And if I get into that toxin that's in that poison ivy, that oil gets on my skin, I immediately start to break out. So it's immediately targeting my skin. I'm going to have a reaction to it. So we're going to look at these different organs and how that plays out. But you'll have a primary. So the primary is that it affects my skin because I get a rash almost immediately. The secondary is that it could make you sick. If you get enough of it and you have this all over your body, you could start to have other organ systems that get affected just because of the intensity of the allergic reaction. So if you have an intense allergic reaction, then that would be a secondary, unless it happens first. So, all right, so we're going to talk about the liver. So what does the liver do? So the liver, I kind of think about it when I'm looking at all those pictures of all the organs of just being the biggest lump of Play-Doh. You know, when you were a kid and you had to do a science fair, one time I made the digestive system out of Play-Doh, and the biggest lump of Play-Doh was the liver. But it's not just a lump of Play-Doh. The liver is doing a lot of things in your body. It's processing fats that are absorbed from your food. It makes glycogen. So what's glycogen? So we all kind of know about glycogen now because everybody probably tried a keto diet at some point in time. So glycogen production is how your body takes that excess energy that's in your bloodstream and converts it to a form that it can save and use later. Bile production, and you can't digest your food without bile. Synthesis of proteins that help your blood stay healthy and do what it's supposed to do. And it metabolizes those xenobiotics. So your liver is working to protect you from things like bee stings and poison ivy and all those things. So it's got all these jobs. So anybody that works in an office or works in a company, you've got all these people that do these different jobs. And you don't think about those jobs until that person's not there. So maybe we think, well, that guy's just the janitor until he doesn't show up and all of our waste baskets are overflowing and there's a big nasty mess in the bathroom and there's all sorts of things going on. So we may not think about our liver very often, but it's doing a lot of jobs. And if it stops doing those jobs, our health is going to be significantly impacted. I call this malfunction junction because that's what my husband calls the intersection in Birmingham. You know, the one where if you make one wrong lane, you are going to go to Atlanta instead of Mobile, or you're going to go to Mobile instead of Atlanta. So I call this malfunction junction. When your liver goes wrong, what do you see? So there's 3 specific types of liver malfunction or liver failure. You've got cholestasis, that's where the bile system stops working properly. You've got hepatocellular necrosis. This is where cells actually start dying. And then you've got specific target organ toxicity. The reason I call those out is that when you look at your SDSs, sometimes they will call it out that way. And if you think about it as far as on a practical level, being a safety manager, trying to decide whether or not to let this chemical into my plant, what you need to know is that all of those mean liver failure, and liver failure is a very serious problem because that stops your lipid processing, your glycogen production, your bile production. All these things stop, and your body has to have all these things happening for it to function properly. So we'll move on from the liver to the kidneys. So what do the kidneys do? I guess they're more like the janitor of your body. They're removing the waste products from your blood and producing the urine. They're a filter. So none of us eat 100% of the time what we should eat. So we're taking things into our body every day. And if every single thing that is bad for us stayed in our body and did its worst, we'd all die. But our kidneys are fighting that. Our kidneys are filtering our waste products. They're producing water. They're producing urine. They produce something called erythropoietin, which is a chemical that stimulates your bone marrow to produce red blood cells. They help maintain your electrolyte balance. So OSHA's got that new regulation out about heat stress. So your kidney function is going to be really important, staying hydrated, keeping your electrolytes balanced. And that's what that new heat stress standard is going to help us do, we hope. They make vitamins to control your growth. So people that have poorly functioning kidneys, children that have poorly functioning kidneys, they don't get very tall, maybe. I have personal experience with this one. My next door neighbor had kidney failure, and we all thought he had Alzheimer's. So if your kidneys stop functioning, it doesn't just impact your stomach and your digestion and your waste system. It'll start to, as these toxins start to build up in your body because your kidneys aren't processing them and taking them away, your brain will stop working like it's supposed to. And our neighbor, we thought he had severe dementia and severe Alzheimer's disease. But when they took him in, he got a urine test. His kidneys had completely failed. When he started on dialysis, he went back to being the guy that we knew him to be. His memory came back, all these things recovered. So when you get into something called renal toxicity, this is when your kidneys have stopped working and the toxins begin to build up in your body. And it doesn't just affect your waste processes, it can have a secondary effect on your central nervous system as well. So we talked about the memory failure and the fatigue. And so we get into the neurotoxicity. What does the nervous system do? It communicates throughout your body. It's your communication network. So we all work at companies. We all have a lot of interactions within our family. And we are always saying, well, there was a failure to communicate. When there's a failure to communicate, things go wrong very quickly. And the key functions of your nervous system are to communicate throughout all parts of your body. And it's doing a lot of things at any point in time that you're not even thinking about. You got sensory perception, motor control, cognition, emotional regulation, learning and memory, homeostasis. It's keeping your body in check. If you encounter neurotoxins, which we'll talk about a few examples in a minute, that can disrupt or kill your nerve cells. And we've all talked about that. I've seen a joke on the internet many times, and it says, nerve cells, if they die, once they die, they're gone. Fat cells, they just keep coming back. Nerve cells do not come back. Once they die, they can't regenerate. Pulmonary toxicity, your lungs. Your lungs are doing a similar job to your kidneys, but they're doing it with air instead of with food and other products. So they provide oxygen and they remove the waste such as the CO2. So they take in the oxygen, they put out CO2. What happens when things go wrong? You get inflammation, you get scarring, you get pneumonitis and fibrosis. These are the ones that industrial hygienists will tend to camp out on because we talk a lot about asbestos and silicosis and all those conditions that are scarring of the lungs. So your lungs are another target organ that we look at a lot of chemicals, and a lot of those that have specific OSHA standards are pulmonary toxins. And then finally, we've got hemotoxins. What is blood? It's like the Swiss Army knife. It does a whole lot of things. It transports oxygen and nutrients through the body. It removes waste, fights infections, regulates your body temperature, prevents your blood loss. It delivers the hormones throughout your body. And we end up with primary and secondary toxicity in the hemotoxins or the blood. and any of the chemicals that we talk about that have a hemotoxic effect, they have adverse effects on either the blood or the bone marrow, or both. So if you're planning to take the CIH exam anytime soon, it's all a lot better, I hear, than it used to be. We used to have to study on flashcards, and we would have all these chemicals on flashcards. And on the front side of the flashcard, you'd put the chemical, and on the back side, you'd put the target organ, you'd put all the symptoms and all these things. And then you would walk into a test room, and and when you leave, you can't tell anybody what the test questions are, but the general style of the questions tends to be, here's a situation you've just walked into, your employees are experiencing this, 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 and this. Which one of these chemicals have they been exposed to? And those are tough questions, or I always thought they were. So we look at some of the target organs and some of the common toxins that target that specific organ. MDA, vinyl chloride, acetamide, dimethylformamide, those things all target your liver. So vinyl chloride, you run into that fairly regularly. So you've got liver toxins, and those are some examples. Your kidney toxins are heavy metals, agrochemicals, arsenic, fumaric acid, and heavy metals. You run into that a lot in any kind of construction industry where welding is occurring. You also end up running into that in foundries and aluminum rolling plants. All those things tend to have some heavy metals that you're having to deal with. The neurotoxins, you've got lead, you've got ethanol, botulinum toxin, diethylmercury. So you think about mercury and it being a central nervous system toxin, and the trick to remembering that is the Mad Hatter, because the Mad Hatter was mad because they dipped the hat pins in mercury to make them shiny. And when they dipped those into the mercury to make them shiny, that mercury was absorbing through their skin, and they were slowly losing their central nervous system function. So that's why the Mad Hatter is kind of that icon, or that the poster child for central nervous system toxins. We look at the lungs, and we have asbestos, cigarette smoke, ricin, and an ammonia bleach mix. So ammonia and bleach, why would anyone ever mix them? Well, they don't usually do it intentionally. I worked for a long time at a university, and during finals, our students would get really stressed. I don't know why. I mean, it's not like they had not studied consistently throughout the semester and kept their grades up. At the end of the semester, though, invariably there are a few that go into a panic. Well, in one kid's dorm room, there were ants. He had ants. He hadn't cleaned up his dorm room in the whole semester, so he had ants. Well, he noticed that if he sprayed ammonia on them, some of them died. And he noticed that if he sprayed bleach on them, some of them died. So he decided to mix ammonia and bleach, and spray that on the ants. So what did he do? He created a noxious gas that required the entire dorm to have to be cleared out. So people don't usually intentionally mix ammonia and bleach, but sometimes they're thinking, well, this works and this works. I'm going to put these two together. Looking at the blood toxins, you've got hydrogen cyanide, arsine, and those heavy metals again. So those heavy metals, they keep showing up over and over. So if I was going to study for the CIH exam, I would make sure I knew all the symptoms and all the effects of heavy metals for sure. Carcinogens get a lot of press these days. The first time I heard the word was in a toxicology course 30 years ago, but now everyone seems to know what a carcinogen is. But a carcinogen is a substance that causes cancer. And there's a lot of debate on that. You know, you'll see labels that say a carcinogen only in California. And of course, that doesn't mean that it's only a carcinogen in California. It means that California has a lower threshold for the research that will tell you this is a carcinogen. So they're a little more stringent. Some of your common carcinogens are asbestos, benzene, diesel exhaust, formaldehyde, hair dyes, acrylamide, and alcohol. And all these things can be linked to cancer. And sometimes you'll see the term suspected carcinogen, and that usually means we don't have enough research to say for sure that this is going to cause cancer, but there's a strong enough correlation that we want to warn people and let them make their own best determination. Household chemicals in the news. In 2021, something new came to everyone's attention, something called PFAS. What is PFAS? Well, they are polyfluoroalkyl substances, and they generally come from plastics and petroleum products. In 2021, a bill established the requirements and incentives to limit the use of perfluoroalkyl and polyfluoroalkyl substances, commonly referred to as PFAS, and to remediate PFAS in the environment. PFAS are man-made and may have adverse human health effects. This came directly from the EPA's website. So if you haven't heard of this before, you probably want to get on the EPA's website, dig a little deeper, make sure that your process doesn't produce PFAS, because the regulations in 2021 said, okay, we're going to give you incentives to limit the use. Now, in 2024, the EPA issued the first ever national legally enforceable drinking water standards to protect the communities from PFAS. The final rule will reduce PFAS exposure for approximately 100 million people, prevent thousands of deaths, and reduce tens of thousands of injuries. EPA currently announced that a further $1 billion will be sent to help states with PFAS testing. And I don't know how the new administration will deal with this. In April of 2024, this was announced, and the new administration, I don't know whether this is one that they're going to be consistent with or one that they're going to block. So we'll just have to pay attention to that. Don't let it drop off your radar, because the PFAS regulations are relatively new to everyone, and they're in be a household chemical. And we're going to do our poll question. Which of the following household chemicals are you most concerned about?
Weed killers. And then the next one would be cleaning products.
That makes sense to me, because we know that weed killers and insecticides are intended to kill something. They're either intended to kill insects or weeds. So obviously they're going to have an impact on our pets, on our children, on us. And then the cleaning products, more and more we're looking at the cleaning products and we're asking questions about, why can I buy this cleaning product here in America and I can't buy it overseas? And if that's the case, what do they know that we don't know? Is it just a political thing, or is it valid? So all those are good answers. Okay, so you look at different things when you're determining household chemicals in your home. So if you're in your home and you're deciding which household chemicals to use, everybody's not going to make the same choices. What we want to be able to do is make informed choices based on data when we can. We don't want to just get scared because somebody said that one's a bad one or this one had a better commercial and those kind of things. We want to look at the data that we have on toxicology and chemical safety, and we want to think about those things as we're choosing chemicals to put in our house to expose our families to. That is going to be influenced by a lot of factors. Allergies. I have a lot of allergies. I don't ever put any candles from Kirkland's or the Yankee Candle or any of those places in my house because I have terrible allergies. So if I burn those candles, they may not be harmful to the average guy, but I'm going to spend all my time coughing and sneezing. So I'm going to make a choice not to use those chemicals because I have an allergy. Sensitization is different than an allergy in that it occurs over time. So over time, I become sensitized to the chemical. Before I could be around it, it didn't bother me, but now I don't have to be, I've become sensitized, so it takes very little of the chemical to impact my health at this point in time. You run into that a lot with the isocyanates. Isocyanates are a sensitizer, and you run into isocyanates anytime you're mixing products to make foam. So in a lot of your industries, you run into sensitizers when you talk about isocyanates, but there are also sensitizers you want to watch out for in your household. Immunosuppression. When you look at biotoxins or xenotoxins and you look at mold, there's a big difference in how mold is going to impact a healthy 25-year-old person and how it's going to impact a cancer patient who is experiencing immunosuppression. It doesn't take as much to make that person sick. So we also look at that. If you've got immunocompromised people in your household, you're going to make different chemical choices than if everybody's absolutely healthy and wealthy and wise. Family history of illness. I grew up in a family where when I was, but 6 months before I was born, my granddad died of lung cancer. And that's kind of how I got into industrial hygiene. Is I spent my whole life knowing that cigarettes cause lung cancer, and why in the world are people still smoking? Because this was drilled into me from the moment of my birth. Everyone was still suffering from this terrible death of this very young 47-year-old man from lung cancer. So your family history is going to influence your choices. Somebody that's lived with a bunch of people that have smoked their whole lives and nothing ever happened to them, they're going to be a lot less, they'll be more likely to choose a cigarette than I would. Because my family experience is that we've had people die of lung cancer, they were heavy smokers, and that's a very obvious correlation to us. News reports, different things get press. Do the worst chemicals always get the most press? Not necessarily, but it will influence things. There's some letters that are having to go out from some of the municipalities right now saying that the municipality has to test their water for lead. Well, because they had to send the letter out, this has alarmed citizens, and they're calling in thinking there is a lead problem. Well, the truth is that the municipalities don't know if there's a lead problem yet. They're having to do the testing to determine whether there's a problem. They had to send the letters out ahead of time. So now they're having to kind of deal with this on the front end, which maybe that's better. But those kind of news reports, things that are happening, that's going to influence people's sensitivity to chemicals. Your level of education, and that can work in both directions. People that become more educated sometimes are more prone to reject chemicals, and sometimes less. That can run in either direction. Political beliefs, religious beliefs, all the things that impact the decisions that you make are going to also impact the decisions you make about what chemicals you bring into your house. So I'm going to jump to SDSs now. So how do I tell if it's a good SDS? Because we're going to try to decide whether to bring these chemicals into our house. And in order to decide whether we're going to bring that into our house, the resource we have is an SDS, because an SDS is made for all the chemicals. So now that we all have Google, we can all Google and get an SDS, whether we're at home or at work. Back many years ago, I remember a time many years ago when companies didn't want to post their SDSs because they didn't want to alarm their employees. Well, now taking that approach is just naive, because everybody can pull out their phone and look up any chemical that they're working with and find out what the SDS is. So now everything's a lot more open, and I think that's for the best. First of all, are there 16 sections on this SDS? When I was pulling up household products for this presentation to look at the SDSs, a lot of them were the old ones that only had 8 sections, 8 or 9 sections. If it only has 8 or 9 sections, that means it's a very old SDS from the last century. Before the turn of the century, in the 1900s, we had shorter SDSs. Now they're longer. They have 16 sections. So if you open up your SDS and it doesn't have 16 sections, immediately stop and think. Check with the company, make sure there's not a newer and more accurate SDS available, because those are old. The second thing that you want to do is look at the GHS codes in section 2. So if you open up your SDS, any SDS, and you look at section 2, they're going to be GHS codes. And if it says something about your liver in section 2, and you scroll over to section 11 and it doesn't say anything about the toxicology of liver, it may be an okay SDS, but it's probably not a great SDS, because these should match. If you're mentioning liver toxins in section 2, there should also be liver toxicity data in section 11. Then you check in section 8 and look for those OELs. So that just tells you whether it's regulated or not. There may be toxicological data and they just haven't regulated anything yet, but you're looking for section 2, section 11, section 8. You want those to be consistent. If those are consistent, it's probably a pretty good SDS, and I would go ahead and use it. If any of that stuff is inconsistent, then I would stop and I would call the manufacturer and see if I can get a better SDS. That was something I learned in that recent webinar that I went to, and I thought that was super helpful because I've gotten them before where I just thought this SDS looks a little sketch. I mean, and that's just my gut instinct is this one doesn't look quite right. But these were good, solid rules, I thought. Does it have 16 sections? Check the sections 2, 11, and 8. Make sure the data in those matches. If you got some mismatches, it might be time to look at the integrity of that SDS. We'll go with another poll question. Do you ever bring chemicals from your household to your workplace?
Medications, cleaning products, or none of the above.
Makes sense to me. At my previous job, we would run into this every once in a while. So I was supposed to approve all chemicals that came into our work site. However, sometimes we would have chemicals and we'd look through our chemical inventory. We couldn't find it anywhere and people had just brought them in. The reasons they would give were a lot of different reasons, and they're somewhat valid. The chemicals that we provided didn't work for what they needed it to work for. There were pest problems, and they didn't feel like the company was dealing with them, so they brought in their own can of Raid. Their work area stunk, and they needed air fresheners to make it bearable. The company banned the chemical I need to do my job, and they provided something they say is an alternative, but it does not do what I need it to do. And any other reasons that you've ever gotten for that? People that bring chemicals onto your workplace and they don't, and you can't figure out where they're coming from. Why are they bringing those in? Another big one is in maintenance. In maintenance, those guys a lot of times have a company card that they can use to go get parts to fix things in an emergency. If you don't watch that fairly carefully, they'll take those cards and buy some chemicals at their local AutoZone, and now you've got chemicals that you didn't know were present in your workplace. We're going to look at an SDS. This is an SDS for an air freshener because in my experience, this was the thing people most often brought in and didn't think a thing about. Because they thought, well, if it's an air freshener, it's not toxic. We're allowed to use it around our children and our pets. They wouldn't sell it if it wasn't safe. So it's fine for me to bring this chemical into my workplace. I blocked out the information on exactly what air freshener this is, but it's a pretty common one that I've seen quite a bit. First hazard identified, of course, is that the gas is under pressure. It contains gas under pressure and it may explode. So if you're at home and you get ready to throw this can away, what do? You toss it in the trash when it's empty. If you're at work and you get ready to toss this, if you toss it in your trash, now you're in violation of, depending on your state, you may be in violation of RCRA if your site is regulated for aerosol cans. So that's the first difference is our waste regulations are different at home versus at work. If we have a chemical and we use it at work and we put it into the workplace's trash, now we may have set them up for a violation in a perfectly innocent way. So it's something just to remind people, hey, aerosol cans, depending on the state, could be considered hazardous waste. We need to be sure we're handling our aerosol cans properly. That's one of the chemicals you need to train your office personnel on because office personnel have a tendency to bring in aerosol cans. I see them sitting around offices all the time when I do inspections, and people don't seem to think anything about it. So this particular air freshener that I chose is 5 to 10% ethyl alcohol. So ethyl alcohol, that's the one we drink. So it's what some of us drink. So that one doesn't sound too bad, right? We got ethyl alcohol, 5 to 10%. The rest of it's probably scents, but they aren't noted as having a particular hazard. We do notice down here that this particular chemical may irritate the eyes. An intentional misuse by deliberately concentrating and inhaling the contents can be harmful or fatal. So again, we look at that. The dose makes the poison. So yeah, if you're just spray a little bit in your room to control the scent, that's one thing. If you're huffing this stuff, that's a completely different situation. So you've got your air freshener, tells you how to do firefighting. It tells you what to do, remove all sources of ignition, avoid contact with skin, eyes, and clothing. If you are using this in an industrial setting and you have a stock of it somewhere, you've gone to Sam's and bought back a case of it, then you may start to wonder about the quantities that you've got stored. Finally, we look at section 8. So we looked at section 2, it mentioned ethyl alcohol. Now we come down to section 8 and it mentions ethyl alcohol again. So far, decent SDS. We've gotten as far as section 8. We compare 2 and 8. They both mention ethyl alcohol. This one provides the OSHA and the ACGIH TLVs. Pretty high, 1,000. So pretty high. So again, we're trying to lean in towards thinking this is a relatively safe chemical. Oh. And then finally, we get down to the toxicity data, the section 11, and it says the acute oral toxicity greater than 5,000, acute inhalation toxicity greater than 10 micrograms per liter, acute dermal toxicity greater than 5,000. So these match fairly well. We've got ethanol, and then we've got toxicity data. So this is a fairly good SDS. After reviewing this SDS, our poll question is, would you use this chemical?
Would not use is the first answer, and then second would be home or office.
Home or office.
And then third would be home only.
Completely safe about using it. Others wouldn't use it.
Yeah, majority people are saying would not use.
Okay, nothing wrong with that. So we got a case study. No perfect answer. Well, if you have a perfect answer, please put it in the chat because this one was a personal case study that I ran into. An employee who has been diagnosed with chemical sensitivity to VOCs particularly has informed your workplace of her diagnosis. She works in a cubicle area and her cubicle is adjacent to 2 other people. One of the people does not necessarily believe that frequent bathing is necessary. Because of this person not believing that bathing is necessary, the person on the other side of this individual has decided to bring in air fresheners and liberally spray the area as a hint to the other person that they might want to take their bathing more seriously. The person with the chemical sensitivity gets sprayed by the air freshener. They leave for the day in respiratory distress, and they go to the doctor. They really are having a respiratory distress because they have a sensitivity to the chemicals. How would you address this situation? Another poll question.
It looks like one person did say they would quit their job as a safety specialist and become a beachcomber.
I considered that.
But the most common answer is contact your HR department because this is complicated and must be handled carefully. The second answer people chose was review your company policy on chemical control with employee B and ask them not to bring in air fresheners.
I would agree with that. I considered all of these. First of all, the supervisor had already told employee A not to be so sensitive. This is not a hazardous chemical. What's wrong with you? So that's why I was brought in because someone had already used option A. I don't think any safety professional would have used option A. The second one that we immediately did as a follow-up was to review the company policy with employee B as well as everybody else in that department and say, hey, you've got somebody here that has a chemical sensitivity. So we need to stop bringing in these air fresheners. They're impacting this other person's health. We could not counsel employee C on proper bathing habits based on what the response we got from HR. They wouldn't let us do that. It would have solved the problem because the spraying of the aerosol was a direct response to the unpleasant odor in the space. But the best answer, I think, is to contact your HR department. This is very complicated. You've got possible HIPAA violations, you can't tell everybody who it is that's sensitive to the chemical. They probably know because the person went home, but you have a lot going on there. So I do agree. I did think about quitting my job as a safety specialist and becoming a beachcomber, but unfortunately I still have a mortgage, so I was not able to do that one. All right. We've got good window cleaner and bad window cleaner. So we have windows in all of our offices, all of our buildings, we have windows. And when we clean windows, there's stronger cleaners and there are some that are almost just water. This particular, we're going to look at this one. We're going to think about our rules. Is this a 16 section? I'll go ahead and tell you it is. We're going to look at section 2. So we're looking at the hazards identified. It says skin corrosion, eye damage, corrosive to metals. It's an oral toxin and a dermal toxin. So this is probably not your garden variety Windex. I can tell you it's not. I dug around for this one a bit. This is window cleaner. That's all it says. It's a generic window cleaner. If you come now from section 2 to section 3, your chemicals are butoxyethanol, ammonium hydroxide, and sodium xylene sulfonate. Got a whole lot of butoxyethanol, but we do have 7% ammonia. So those are things to keep in consideration. So this up here said it is corrosive, eye damage, acute toxicity. Here we've got some chemicals that raise our eyebrow. So we come down here, first aid measures. If you look at these, take off immediately all contaminated clothing, rinse your skin with water for at least 15 minutes, call poison control. So this is a different window cleaner than the one that I use at my house anyway. The one I use is just got a little bit of lemon juice in it, I think. We go to section 11, routes of exposure, eye, skin, ingestion, inhalation. There's not any LC50, LD50 test data on this. So review question, what are LC50 and LD50? LC is lethal concentration 50, LD is lethal dose 50, and it means that is the dose at which 50% of the concentration would die. And usually when they do these tests, they start out with rats, sometimes they move up to rabbits, sometimes they use zebrafish, but whatever your test body is, LC50, that's concentration at which 50% will die. LD50, that's the dose. So that usually means they're ingesting it or putting it on their skin. These are consistent with the notes in 2, causes eye damage, causes skin burns, corrosive effects. So we've got a decent SDS. We've got section 2, section 11, section 3, all, and section 8. Matching fairly well. We've got exposure limits in section 8. Butoxyethanol is 20 parts per million. They've listed both the ACGH and the OSHA, so they've given us the regulatory and the recommended. And it says general room ventilation is typically adequate. So again, we're going back to that concentration. So when you're talking about the skin damage and so forth, we're not talking about you sprayed it and you had your gloves on and you wiped the window. That's not when we're going to get this eye and skin damage. It's when we come into contact with the chemical. Then we also have other regulatory information. This one happens to have a reportable quantity of 1,000 pounds. It would take a lot of window cleaner to give you 1,000 pounds of ammonium hydroxide. But if you are a hazardous waste generator and you're having to track it, it will be something to consider. I want to get to the case study. In an effort to reduce environmental impact and improve sustainability, the custodial director of a large institution worked with a chemical supplier to introduce a new line of environmentally friendly chemicals, which were cheaper and dispensed through a dilution system in the janitorial closets. So the situation is, we've got janitors' closets, they've got empty bottles with sprayers in there. When people need cleaner, they go in, they mash the button on the dilution system, and it delivers the new environmentally friendly cleaners into the bottles, and they take them out and they use them. They have labels over on the shelf. It's a good system in theory. It's actually a really good system. You just have to enforce it. Individual janitors used these out in the buildings, and some of the admin staff said that the windows just weren't as clean as they used to be. Well, the janitorial staff encounter these admin staff every single day. They encounter their custodial supervisor maybe once a month at a safety meeting. So they want to make their admin staff happy. They want to please their customers. So they begin to bring in some really good window cleaner they got from their brother-in-law who owns a janitorial business, and they put that in the bottles so they won't get in trouble for using the wrong cleaner. So after we reviewed the SDS, if the window cleaner that they've brought in and substituted for the environmentally friendly cleaner is the one that we reviewed, what do you think? What do you think the biggest concern is? They're all a concern, but what's the biggest concern?
Most people said all of the above, and they also said lack of an SES on site could lead to an OSHA citation, and potential mixing of this chemical with incompatible chemicals are the other two choices.
Yes, I agree with you. The reason this came to my attention in this particular instance was someone had mixed it because it was supposed to be this environmentally friendly chemical. They had mixed it with another chemical, and they had produced a small amount of gas because they mixed it with a bleach bleach product. We got different employees bringing in different chemicals because they don't like the chemicals we've supplied, and now they're making their own chemicals without meaning to. Mislabeling is probably not going to lead to ingestion in this particular case. That's more like when you're putting your cleaning products in a coffee can. Lack of an SDS could lead to an OSHA citation, but all these could be a problem. I was watching Perot last night. It was an old one, but the lady walks into the potting shed, and the husband has been putting his alcohol in a weed killer bottle, so that because the whole family's upset about his drinking. So she gets caught for murdering somebody. She runs in there and she wants to kill herself. So she picks up the weed killer and downs it, and it turns out just to be alcohol. So that's a mislabeling that could happen. You don't want that kind of thing to happen either. Okay, we're going to get around to old paint in the garage, and I don't have very long, so I'll kind of hurry through it. We look at our section 2, it says it's a flammable liquid. There's an aspiration hazard. It's an eye irritant, a skin irritant. It's a specific target organ toxicity, and there's an acute inhalation hazard. This is the kind of paint that my husband prefers. I pulled it intentionally because it smells horrible when he puts it on, but this is an oil-based paint. Water-based paints, they're not going to look like this. They're not going to have so many GHS signal words. We go down, oops, I think I may have left it in there. We go down to our composition. It's got calcium carbonate, rutile, distillates, mineral spirits, nepheline cyanide, silicate, talc, titanium dioxide, and BMNP naphtha. So got quite a few things. If I was doing a industrial hygiene survey, I would particularly focus on the ones that had more than 5%. So we look here and we go to section 8. We find all the OELs. We've got the ACGH guidelines as well as the OSHA, and they call it a guideline. That would be kind of an error to me because that's a regulatory thing. The ACGH are guidelines, OSHA, those are regulatory. Then we go down to section 11, the toxicological information, and it says that we do have an LC50 kills 50% greater than 1,400 parts per million. So that's something to consider. So we looked at it, we decided, okay, this is a pretty good SDS. It's got 16 sections. Our sections are consistent. So we're going to use this SDS. So we get to our case study. This is the last case study, I promise. Your next door neighbor has passed away and their children are cleaning out their garage. Your neighbor was old school. He never threw anything away that you can think of. Particularly, he didn't throw away paints because his wife was one of those people that was really into decorating. They redecorated all the time. They painted. And he was always worried that he'd need some touch-up paint. And he'd need to go back and get that old paint and touch up. So he lived for a long time. He was in his 80s. And now the whole garage is full of old paint. The neighbor's son has decided to clean out the garage because he's going to try to sell the house. These things happen. The neighbor's son has heard you're in safety and environmental, and he asked what he should do with all of this paint. So I have some options. I've got 2 minutes left. So Bonnie, what did you get?
People are answering, look up local household hazardous waste events and suggest that they take it to that.
That is the best answer. The first one's very tempting. Pretend not to hear and take a week's vacation. It's not an illegal thing to do, but it's probably what you're going to want to do when you see all that paint. Tell them it's not an industrial use, so they can just put it in the trash. I mean, they're not going to go to jail. Tell them that they should open it to air and discard the paint after it's dried. Not a best practice. Tell them it's flammable, so burning it is a good idea. A lot of people will just throw all the stuff when they are cleaning out a house onto a pile and burn it. Not a good idea to throw your chemicals on there. I offered to take it to I'm sorry, this one was also mine. I offered to take it to the household hazardous waste event for them because he's a really good neighbor. What is a household hazardous waste event? If you've not heard of this, municipalities hold events to collect hazmat to keep it from going into the landfills, because people will. They'll just stick stuff in their garbage because they're not industrial hygienists. They're not environmental engineers. Some of them don't know any better, but they publicize these household hazardous waste events so that people can bring their hazmat and bring it to the event and it gets disposed of properly instead of going into a landfill where it's not supposed to be. Google's your friend. I Googled and I found many, many household hazardous waste events. I happened to choose this one from Lauderdale County, Mississippi, that was done December 2nd of last year. But they're everywhere. My particular municipality, they do it once a month. On Saturday mornings for a certain period of time. There's somebody there to take your paint, and they have some restrictions. There's some things you can't drop off, but by and large, these are very helpful to the community, and it's a good way to avoid situations like when Helene came through. We had all this flooding. Well, all this water goes everywhere. It goes into industrial sites. It goes into people's garages. So the more household hazardous waste we can keep out of people's garages and get them disposed of properly, the more likely we are not to get this into our drinking water downstream. So just remember, there are household hazardous waste events, and you can Google and find one in your area. And worst case, you can call your garbage. Whoever picks up your garbage will probably be able to direct you to a household hazardous waste event, because they definitely don't want to be picking up your hazardous waste. Any questions?
Carlos said that Rotary Club usually offers a service.
Okay. The Rotary Club for the household hazardous waste. That's a good resource. Well, thank you guys for your time. I appreciate you. And if you do have any questions that pop up later, or if somehow this intersects with what you do at your job and you need our help, just give me a call and we'll be glad to try and help you out. Thank you.